about the course. Do not relax too much. Okay, so I'm not going to any the makeup or the excuse of the pop-up quiz. It will be used for the part of tendency as well as the quiz. The quiz is not a huge portion, but in case I don't know how many times I'm going to have the pop-up quiz, but to check, I cannot check the attendance in the classroom because it's too many students, so I cannot hold. But from time to time, not frequently, but sometimes I directly use the pop-up quiz to check the attendance as well as review the important contents in the classroom. Okay, any question? Okay, so we'd like to finalize the synchronization issue in chapter 5. The remainder is the example of the synchronization. So I don't think I don't think I have to go over the details of the example based on the discussion that we have done the last week. The operating system has their own synchronization, but mostly they are based on what we have covered in the classroom, like the mutual exclusion or mutex law or the semaphore and something like that. So I'm going to skip this part. Then move to the chapter 6. So in chapter 6, I probably mentioned many times before, the operating system needs to schedule the process or the job in operating system. The main reason is that because we have very limited computer resource. That is the main reason. If we have the unlimited resource, we don't have to worry about this kind of scheduling. The CPU scheduling is not the only scheduler used in operating system. There are many others actually the scheduler, including the long-term scheduler, like which process will be activated as a job scheduler, or like the CPU scheduling, it will schedule the very short-term scheduling, and even within the millisecond, it will change the order of the process that can use the CPU processor. And disk scheduler and other scheduler, but among them, CPU scheduling is the most important. The algorithm that can determine the performance of your operating system. So we will see such as the CPU scheduling and CPU scheduler algorithm in this chapter. And also, the first project, actually second project, whatever, project 1. In the project 1, you will implement the CPU scheduler. Okay? So, yes, one. Yes, right. This one, CPU scheduler. Okay? So after I finish this one, I'm going to, I don't have to explain details about the project 1. After you understand the CPU scheduler chapter 6, you can easily understand the objective of your project. But this time, I'm going to allow the form a team by the maximum 2 persons. Okay? So you can work together with your friend, so group by 2. If you really want individual project, doesn't matter. But there is no compensation of individual project. But it will be based on it will be graded based on the group by 2. So actually, if we go back to the basic concept of the operating system, especially the process, what process is doing usually? Processor is executing what? Instruction of the process. Okay? Process keep the instruction, a set of instruction in the memory. Then the processor, the CPU can access each instruction. Then in your microprocessor class or embedded operating system class or the microcontroller class, you probably learned about the assembly language, right? So you learned the several instruction codes such as what? The move is the most popular one. Move is used for what? Move the data information from memory to the register, or register to memory. So based on using what? There are different types of the move. It's basically addressing problem. So to understand to be the assembly language programmer, you should definitely understand there's such an addressing issue. Okay, then the move is one of them. So basically move can move the data in and out. And what else? Copy instruction. I never seen the copy instruction. Add. You can add the data, right? Or increment. INC. Increment is add by 1. Okay? Or you multiply. So what is the difference? The move and the add. Add, you don't have to read the data from the file or the memory. You can add the data from register to register, right? Have to move the data, but move require input and output. Also, sometimes you need to get the data from the file. Open the file and bring that data from this controller to the memory and read the data. Move the file to the register. Okay, there are two types of the instruction. One is just computation, like the add or subtract. Another type is require input and output. Which one is the frequently happen? It depends on the program. Okay, some of the program has a lot of computation and it consumes a lot of CPU resource. But like the database usually input and output a lot. It reads the data from the hard disk drive. If there exists the data in the cache memory, bring the data to the register, then do something. So it depends. So basically we can divide into two groups such an instruction. One is I/O burst job. I/O burst job means it requires a lot of input and output. And another part of the instruction job is CPU burst job. It needs computation. Then why we divide the classify into two? Such a I/O burst job, what CPU can do during the input and output? Actually nothing. It should wait until data available. Then if available, then bring the data into the register. Then the CPU can calculate computation. So during the I/O burst job, the instruction that require a lot of I/O, actually CPU cannot do anything, just wait. So why don't we use such a I/O burst time? Why don't we give the other process to use the CPU resource during the I/O wait, I/O burst time? That is the idea. However, don't be confused with the CPU. The scheduling algorithm can increase the CPU time. Can we really increase the CPU time? So for example, right, the most frequently asked the thing to my daughter nowadays is, why don't you organize your room, you organize your time, okay? So when you organize your time, so I have the scheduler or organizer, you can use the app or the program. Can you increase the time? Actually not. You can maximize the utilization of the time. Okay? Our goal is maximization of the utilization. Okay? However, some of the scheduler can increase the time or reduce the job. What can be the example? The last few weeks, we got a lot of snow. So is there anything we can do during the snowstorm? For me, nothing. So I usually stay at my we call that room as a computer room because that room is the only the room has the desktop computer. Nowadays the laptop is everywhere. But anyway, we call that room is the corner of the room. So this is the computer room, and actually my house is the corner of this street and this street. This is Toby Drive, this is Parkwood or whatever. So there's a window to the side, so I can see this part. So what I can see is whether postman is coming or not. That is the only communication between outside of my house. And so always the postman is coming this way and turning around this way and this way and this way. Then my post box is here, so put here. Now, it takes usually the 20 to 30 minutes to cover from here to then all the way. Then what if he put the mail, my mailbox, just when he enters this side of the room. However, if he put this one first, then going backward, it will be longer time, right? If he change the route of the delivery route, it takes a longer time. Also, I believe this is the optimized, shortest path to deliver all the mail. So actually, when he make the plan of delivery, in other words, the schedule his delivery, he tried to reduce the job. Okay? So physically he can reduce the job using scheduling algorithm. However, CPU scheduling algorithm, we cannot reduce or increase the job. We cannot reduce or increase the CPU time. Instead, we can maximize the utilization CPU. That is a different thing comparing to other scheduling algorithm. This example is you can find disk scheduling algorithm. Disk scheduling is like this. What is this? What is this? It's a disk. So just like a CD-ROM. Okay. What about this? It's a disk arm, and tip of disk arm you can find head. Okay. There is a disk head. So you can read the data or not. Okay. That's the basic way to save and read the data from CD-ROM or DVD or any this type of the data. It's a 0 or 1. But this one is rotating, this one is moving forward and backward. So when you read the data, if in worst case, data is here, another one is here, 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 it takes a long time. Instead, why don't we read this data first, and next this data. Okay, you can physically reduce the moving time, moving distance by scheduling. This is the disk scheduling algorithm to reduce actually the job. However, unlike the disk scheduling, CPU scheduling job, actually we cannot increase the CPU time, we cannot decrease the job. We try to maximize. How? By considering the I/O burst job, we can replace the time by the new process. Okay. So if we actually make the history for the CPU burst duration, we can find the I/O usually happen a lot, but it has the last CPU burst time, and CPU bound job usually takes some time, but not frequently happen. Okay, so we try to use this amount of CPU by replacing the new process. So we try to use all of the CPU time for CPU burst job. That is the idea. Then how can we do that? we will see the algorithm later. Before that, CPU scheduler is considered as a short-term job. Why? So we have discussed about the long-term scheduler and short-term scheduler. Long-term scheduler is for job itself, process itself, which process will be selected. However, if we select the process itself, it will consume all the resources, like the MS-DOS. DOS is, as we have seen, as you know, DOS can run only one process at a time. So we need to select one process. So it consumes all the CPU resource. Okay, so it will be considered long-term scheduler. However, short-term scheduler, so how often? It's within millisecond. We can change it, the next process. How can we do that? Usually for multiple process. So when we have the process 1, process 2, process 3, we will select one of them for the processor, the CPU. At that time, we can use the queue data structure to manage the number of processes. Okay. Do you remember the 5 states of the CPU? This is a new. After create, if that one is ready, it will move to the running, ready. So how can we manage the ready state? Using ready queue. Okay. Then, if this one is selected to get the CPU resource, it will be running. Okay. If that one is done, it will be terminated state. And in case it needs I/O, it will move I/O wait state. Then once the disk controller returns the data, it is also ready to get the CPU resource. It moves to running? No, it will go back to the ready queue. Okay. Also sometimes, like in case of the time expiration, like within certain second, if the process uses certain amount of CPU time, it automatically move back to the ready queue. Okay, this is a 5 state of it. At that time, when we can terminate no process, so we can run the CPU scheduler to select one of the processes in the ready queue. This is the number 4. And running to I/O wait, this one. Okay. At the time, we need to select one of the process over here, and running to ready. Okay. Then it's empty, so we need to select one of them. And also waiting to ready. Even though there exists a process in the running queue, we can run the CPU scheduler again because it's a change of the ready queue. So there are 4 cases throughout but it depends on the operating system. Some of the operating system consider new to ready queue as the CPU scheduler design the new process. Okay. Sometimes this one is not considered, but these 4 cases are considered when the CPU scheduler is activated. At this time, first and the first one, which means the terminated or running to wait queue, this is called non-preemptive. And the other 2 is a preemptive. So preemptive and non-preemptive means in operating system is, you can understand the preemptive is kind of backup. Okay, it can be reused. It's kind of backup. Non-preemptive is you cannot occupy, you cannot be backup, you cannot be reproduced, you cannot be restarted. Why? Because in case of terminate, there's no other way to be executed, right? It's a non-preemptive. There's no way to use the CPU resource. And I/O wait, until you got the response from the disk controller, it cannot have any chance to be selected. So it's a non-preemptive. Preemptive means if you go back to ready, it may be selected again, right? It may be kind of the possible to be selected for the next process. And waiting to ready, here to here, it may have the chance. So this is a preemptive case. So in case of the preemptive case, it may be selected again. Okay? So who is in charge of that CPU scheduling? It's called the dispatcher. So we call that process as a dispatcher. So dispatcher is another process. It's another module in operating system. Actually, that dispatcher should have guaranteed the CPU resource. So sometimes it has a very high priority. At least it should get certain the priority to get the CPU resource. Otherwise, so if the dispatcher is not running, it cannot get it cannot select the next process. So that is called the dispatcher. Then before we start the CPU scheduler, our objective, our goal is we need to consider CPU utilization. So what is the CPU utilization? It's the time, CPU time. It's a percentile or the CPU time. So that is called the CPU utilization. Ideally 100%, right? We don't want to waste the CPU time. So ideally 100%, do you think 100% is good? It's not. Whenever you have the problem of your operating system, so your CPU utilization is 100%. That means some unexpected process takes all the CPU resources. So your operating system, like the dispatcher, may not get the chance, the CPU resources. So that is a reason sometimes in your program, if your program is kind of infinite loop, like the while loop, for loop, at the time you do better have some sleep time inside the code. Okay, if you process for example, one of my major research area is the video processing. So what is a video? Video is nothing but sequence of images, right? It's called the moving picture. So, for example, how many images for video, HD quality video? 60 to 120 images. So, to display the HD quality video, your computer should display 120 images. If we are using the 1080 pixel, the quality is huge. So takes a lot of CPU resources. That is a reason nowadays we are using graphic card. Graphic card is also processor for the video processing. So the algorithm usually for video processing is kind of the for loop, while loop for each process. So every second in this process, 60 images, 60 moves. So sometimes it's a simple algorithm, so it can process 60, so it consumes all the resource. So it's slow. So if I give the sleep time, like the 100 out of the millisecond, 100 millisecond, then it's much faster, because other operating systems may use such a CPU resource. So CPU utilization, ideally 100%, but practically 100% is not a good condition. What about the throughput? Throughput means it's a number of jobs. It's a process. How many processes are completed within given time? Okay. Turnaround time is the total amount of time to complete, to execute the certain process. Okay. So for the specific process, how long it takes. Okay. Waiting time. What is the waiting time? Process cannot be executed, cannot take the CPU resource all the time. Instead, it will wait in the IO wait or ready queue. So it has something waiting time. The more waiting time is the better? No, definitely not. The less waiting time. Okay, on average for the several processes. Interesting is the response time. What is the response time? So when you are using the website, so when I click the bridgeport.edu, it takes 100 seconds, 1 minute, 2 minutes. So do you like such a website? So usually the people will leave if the response time is more than 7 seconds. Okay? In other words, the people cannot wait longer than 7 seconds. Right? What does that mean? Response time. It's the total amount of time between request, execute, and until when? First response. It doesn't matter how long it takes to be completed. Okay? Once there is a response, so it is considered. So it's a first response until the first response time. That's also important nowadays. Okay? That's the same problem in the database. Okay? It depends on. If your transaction, if your system is critical for the online transaction, okay? At that time, response time is very important. On the other hand, so if your system, operating system or any system is for batch job. Batch job means it's usually takes a long time. It's a huge amount of process, but that should be done within certain time. At that time, response time is not enough. Either it's not important. Turnaround time is more important. It depends on. So when we judge the scheduling algorithm, we do not use the one of these. Some depending on the characteristic of your system, we can consider some of them. So our goal is, as one of the students mentioned, so we'd like to maximize the CPU utilization, CPU time, and also maximum the throughput, number of process. The more the process, the better, and the minimum turnaround time for in case of the specific task, and the minimum waiting time, and minimize the response time. But usually we use such a response time and waiting time to judge which algorithm is good. So these are the algorithms that we are going to discuss in this class. Basic algorithm is what? First come, first serve, right? As you have learned in the data structure course, first come, first serve. That makes sense, right? If you come earlier, you will see the professor, right? That's the first come, first serve. But sometimes it's not lucky. It's not fair. So I need a couple of seconds to get my signature. The one student complained, it will take just a couple of seconds. Can I do first? That also makes sense, right? No? In my case, because I need to discuss about my graduation, my GPA is 1.7. So it will take forever. So the other student need to wait for an hour, so it will take the. So that is shortest job first. Okay. Sometimes I need to meet the several times the processor. Okay. So it will take a time, but this time I need this amount time, this amount time, this amount time. So it will be reduced, keep reducing. So why don't we consider remainder time, shortest remaining time first. Okay? Then that is the SRTF, shortest remaining time first. Somebody already reserved using online reservation to meet the professor. So I have the highest priority. So I assign the highest priority to him and the lowest priority to the other student. So using, no matter what time you are coming, just consider priority, okay? Just like when I meet the Professor Mahmoud, so actually I bypass all the students. I'm not sure whether I have the highest priority. Then we can consider highest priority. Somebody complain all of this and not fair. So why don't you give the 1 minute? So first a minute, 1 minute for him, 1 minute for him, 1 minute for him, 1 minute for him, then 1 minute, 1 minute, 1 minute, 1 minute. It's a round robin. Okay? So give the fixed amount of time. But then round robin. Why don't we consider all of this? So just a simple, so multi-level. We consider the here the door, long line and short line, another line. So first I will select one of the line first. Then for this line I will use first come first serve. You can see such a multi-level queue in Disneyland. If you purchase faster train, okay, it has a different lane, right? So that is called multi-level queue. Then multi-level feedback queue, we will see later. It's not easy to explain. So, any question? Yes.
Can you explain again algorithm number 3?
Then that is done from the next slide.
But no, the second last one is a multi-level queue, right? So
Multi-level feedback queue or multi-level queue?
Yes, multi-level queue. So we have multiple queues, and then we use different algorithm for every queue, or what? What do
We
you
will see. So that's not enough, definitely. So I just overview of all the algorithm that we are going to cover. I'd like to show the CPU algorithm itself is not complicated. The algorithm itself is very, very straightforward. One more thing before we start. Any common thing? Can you find any common the strategy in this the list of the algorithm? Time? Running time? Any? Actually, they are, all of these are based on the same strategy. Security?
Scheduling. Scheduling.
Scheduling? Anyway, it's a scheduling. Scheduling based on what? All of these are based on priority. What is the priority of this? Arrival time is the priority. What about this? The size of job. Okay? Amount of job. This one? Amount of remaining job. This is priority. And round robin is the order. Just the order. Okay? Because we are round. Multi-level queue by considering all of this. So anyway, scheduling algorithm depending on what kind of the priority you use, it may